right, so a little bit about me. So my name is Amir Kashani. I'm the VP of Engineering at Anika. So despite the title, I am a software developer by trade. So I've been doing web and other development for close to 15 plus years at this point. So I started out browser-based apps. So in the early 2000s, before single-page apps were a thing and before it was a good idea, I was trying to do as much JavaScript within the browser as I could, right? So as soon as the Ajax came out, basically, I was all over that. I'm also an AWS user for a long time. So since 2008, when the very first couple services came out, which are EC2 and S3. So a little bit about Anika, who we are. So we're what's called a premier consulting partner. So basically, we're a partner of AWS. And we work with them to help enable customers to get into AWS. So there's really kind of three factors to that for us. There's one is the migration and enablement to get into the cloud, right? So that's kind of DevOps and automation workloads. Then there is what we call our managed services. So once you're in AWS, we help keep you there, right? Make sure the lights stay on and do 24/7 monitoring, and then progressively improve your AWS environment, including things like cost optimization. And lastly, it's my group, which is called Cloud Native Development. So our focus is on not necessarily migrating existing applications into AWS, but rather leveraging the cloud, AWS, from day one and building new generation applications. And that's what we're going to talk about today. So here's the agenda. We'll talk about serverless, just at a conceptual level, what it is, how we got here. We'll get into some of the AWS-specific offerings around serverless. I'll talk about some toolings, and then we'll end it with a little demo of a serverless application. So serverless, the obvious answer to what it is getting rid of servers, right? Now, obviously, servers still exist, right? Someone is hosting it for you. There's a server somewhere. But the idea is to remove the burden of managing infrastructure from the developers, from the operations, and really from you as the AWS customer as much as possible. Rather than you having to worry about whether a server is online, how many connections are going on to a database, things like that, let AWS focus on that, and you focus on building your application. That's really the idea with serverless. So before we dive too deep into that, though, let's look at an evolution of that process. So how many people have kind of worked with data centers, have actually racked and stacked a server in a data center? All right, so not too many. So back in the day when we had to physically call up Dell or HP or one of those vendors to get a server, a few weeks later something would show up. You'd have to schedule some time, typically in the middle of the night, to drive up to LA and stack and rack a server on a physical rack in a co-location center. That was a pretty tedious, obviously as manual as you can get process. In terms of provisioning the infrastructure, and it was also challenging in terms of what happens if that infrastructure fails, right? If that server fails, I have to drive back up there and do something about it. So it wasn't ideal, but it was the world we lived in. Then came along virtual servers, this notion of things like VMware, for example. Take a physical server and slice it up into a bunch of smaller pieces and run operating systems on that. The interesting thing about that is not only do I get to utilize a physical server more thoroughly by the fact that I can run multiple disparate operations on it, right? I can have a Windows virtual machine running. I can have a Linux virtual machine running. I can do a whole bunch of stuff. It also gave me some portability. So now I could have, instead of just one server that if it failed, I'm kind of hosed, I could have this notion of moving virtual machines around between physical servers, right? So I could have two servers, and I could take my virtual machine and fairly transparently move it to another one if that host fails, or if I wanted to kind of diversify the load, right? So it was a nice benefit. I was still managing the hardware, though. The hardware was still on my responsibility, but I had a little bit of a little higher level on top of it as well. Then came along AWS and other cloud providers, and they offered virtual servers in the cloud. So for AWS, this is EC2. How many people know what EC2 is? OK, cool. We'll talk about it a little bit. So EC2 is basically a virtual server in the cloud. You go to AWS, you tell them, I want a server. I want it to be this large, right? So they have different units on how many CPU you want, how much memory you want, how fast network throughput you want, and within a couple of minutes, what operating system you want, and within a couple of minutes, you have a virtual machine up and running in the cloud that you can SSH to, you can remote desktop into, and basically run your workloads, build your applications. So suddenly the physical hardware, the physical infrastructure is completely out of our domain, right? So all we have to worry about is this virtualization layer, and the hardware is managed by someone else. So each progressive step there was better. We got to abstract out the hardware, we got to abstract out the virtual machine to the point where we're just focusing on deploying our code and our applications and managing the OS. But there still is some work to do. So in terms of the utilization, so we're able to get higher utilization out of these instances, right? When we went to the VM model, when we went to the virtual servers in the cloud, we were able to trade what's called capital expenditure to operating expenditure, rather than me having to go buy some hardware and deal with all that cost, $15,000 for a server day one. Instead, I could amortize that over years. I'm paying Amazon by minute of usage. So if I spin up an instance and I only need it for 5 minutes, I only pay them for 5 minutes of usage, which is a couple bucks. And then I shut it down, all good. So it really improved the agility of being able to iterate. The limitations still exist, though, in terms of I'm still responsible for the operating system, right? If there's a new zero-day vulnerability, it's on me to go and patch that instance to deal with the downtime. I'm still responsible for managing my utilization and load balancing. So if I have an application or web app that suddenly there's a big spike in traffic because Reddit picked me up, it's up to me to figure out how to scale that up and quickly respond to that traffic. If a virtual machine or the underlying hardware dies, yeah, AWS helps a little bit in terms of you can have snapshots of that you can restore, but the disaster recovery strategy is still my own. I have to figure out how to orchestrate that, how that ties into my business, my operations. So it's still, while it's a lot better, there's still a lot to do. So and that takes us to the sort of the evolution of serverless, this notion that if I can offload the server, the virtual machine, the operating system, all of it all together, then suddenly my responsibilities go down quite a bit. I don't have to worry about provisioning any servers and the utilization. Along with that, I don't have to worry about paying for idle resources. So for example, if I have to deal with potentially having 5,000 people come to my site in an hour, I need to scale that up and be ready for that. So I'm paying for that. With serverless, I don't have to do that. And then obviously the operation management is a lot easier too, in that I don't have to worry about any of the infrastructure, including the operating system. The way serverless works is it's based on this principle of deliver on demand, never pay for idle, right? So whereas a web server needs to be running for it to be able to handle a request, a serverless application isn't running. Not that it's visible to you anyway, when it's not serving a request. It only spins up when someone wants something, and then it goes away when they're done. So basically, you're paying only for the requests that come in. And if there are no requests come in because your site is heavy during the day and completely idle at night, well, it's completely free to run that for you at night. Scaling is built in, right? So if I'm not responsible for the infrastructure, if I'm not responsible for the OS, the virtual machine, the hardware, then I don't have really much control over scaling. So really, it's up to the platform to scale for me to be as fast as I need it to be. So in AWS, there's a lot of building blocks. We'll talk about some of these in detail. But generally, here are the things you're going to want to look for. You're going to need some sort of compute, right? You're going to need somewhere to run some code. In AWS, that's this thing called AWS Lambda. I'll talk a little bit more about that later on. You need some proxy layers. And basically, everything else other than Lambda on this slide are ways to invoke your code, right? So API is HTTP, right? You want to build a RESTful API, you use API Gateway. If you want to store some data for long-term storage, you use S3. If you have a message queue-based application, so messages come in, you queue them up, and you kind of process them incrementally, here are some services for that. So really, there's a whole bunch of building blocks that are beyond just the server layer of it, right? It's beyond just the thing that runs your code that makes serverless applications possible, including a database, by the way, DynamoDB, which is a NoSQL database that's completely serverless. So as developers, as people building software, it really changes how we go about delivering that software. Since we don't have to worry about the operational complexity, we can iterate a lot faster. We can put out code a lot quicker, which means we're getting feedback a lot faster, and we can innovate quicker, right? So we have this kind of feedback loop that we're doing as developers, where we're putting stuff out there, waiting for feedback and making it better, and we can tighten that up a lot by not having to worry about provisioning and managing infrastructure. So this isn't a niche thing. So I'll talk about some use cases in a second, but let's look at some use cases rather. So it's not just for web applications. You can have entire backends built with it, including the front end and the static assets, as well as the response to that. So if you're building a single page application with Angular, you deploy the JavaScript and the CSS and HTML on S3. You serve that up through a content distribution network such as CloudFront, and then you process all of the backend requests with Lambda API Gateway DynamoDB. So this is basically your web app layer. A lot of people are using it for data processing. So I'll talk about IoT a little bit later, and we do a lot of that where events come in from real time from thousands of devices out there, and you want to do something with it, right? So having something like Lambda where it's serverless compute that can handle the workload as it comes in is really great. Anyone use Alexa, Amazon Alexa? So basically the programming model, if you're going to want to build your own custom skill, you're going to deploy that on AWS using Lambda, right? That's the easiest way to go. It's a couple clicks and you have your first skill going, and then it's just JavaScript from there to customize it. And then chatbot. So we talked about Slack a little bit, but for example, a lot of Slack integrations and bots for various services are built on top of on Lambda and serverless. As I said, it's not niche, right? So this is, Lambda is a few years old, so it sounds kind of new, but there's a lot of big companies leveraging it. So these are some of these names. I'm sure you recognize a lot of them. These are AWS customers. Here's some specific use cases. I won't really dive into them, but again, these are names that you'll recognize, and they're doing real workloads, right? So Expedia, everyone knows you book travel through them. They've migrated a big part of their application architecture to serverless. It allows them to scale to immense values without having to really worry about the architecture. It simplifies their disaster recovery and load balancing workloads. So it's not just for enterprises. I want to stress that as well. We'll see an example later on that it's a few lines of code to get started and deploy your first app. And AWS is super cheap for individual developers. They have free tiers where for most of what you'll do, you'll pay nothing. And if you get a bill, it's probably going to be a couple bucks a month tops to deploy, definitely for dev environments and even moderate-sized apps, so not just for enterprises. So let's talk about the AWS platform and how it offers, how it relates to some of these serverless services. So when you're looking for a platform, these are the sort of layers that you're going to want. You're going to want cloud logic, right? This is where we're going to run our code, do some computing. You need various data sources to enable to be able to trigger your code, right? So those are API calls, those are file requests, those are messages coming in. You're going to need some tooling to help you manage all this, right? So there's more than, as I said earlier, more than just the code layer that's required. But we'll start with the code layer. So in AWS, the cloud logic layer is represented by a service called Lambda. How many people have heard of or used Lambda? All right, a few people. So what Lambda is basically a function, right? At the simplest, it's a function. So imagine you have a function in Node.js. There's some defined input arguments, and there's a callback you give it. And what you do is you upload this code to AWS. You tell it when to invoke it. So let's say an API request. So an API request comes in. I want you to call this code. You have some opportunity to receive an event, do some work, and then respond. It manages all the servers, all the underlying infrastructure for you. So all you did is deploy some code. And that's what Lambda is. It basically allows you to deploy functions and have them be invoked as a result of various event sources. And fundamentally, it is event-based, right? The whole thing, it's sitting there idle until one of these events comes in. So we mentioned the API one, but here's another one, for example, DynamoDB. That's another offering from AWS. It's a NoSQL database, also completely serverless. Let's say you want to react to some data being inserted. Let's say when a new order comes in, you want to send an email to the customer, right? So you can do that in a couple ways. If you're building your application, well, your application inserted the order, and then right after it inserts the order, it could send the email. But now we're coupling the logic of sending email to the notion of inserting the order into the database in the first place. So to decouple it, you could use something like DynamoDB streams, which basically fire off events as data is inserted into a database and invoke a Lambda. So now what I could do is when I say whenever a new order is inserted into my table, I want you to call this code. This code will look at the order details, get the customer's information, and send them an email. And now I've built effectively a microservice application, right? Two services, they're independent of one another. They're not coupled tightly. They can be deployed and enhance one another, and Lambda and these various event sources enable that. So we won't go through that. So data sources, here are the various data sources. This is a subset of them, honestly, from AWS. So API Gateway, like I said, again, that's a RESTful API layer. These are all about storage. So S3 is their file storage, what's called object storage. So basically infinite scaling storage in the cloud. You never have to worry about how much disk space is used. You can react to files being added and removed from that as well. DynamoDB I mentioned. These are all events. These two are notification services and email services. So these are all various serverless applications that can also be event sources into DynamoDB. So the interesting thing is, we'll look at it in a little bit when we get into the demo. If you look at the AWS services that are out there, especially the ones that have been added over the last few years, they tend to be serverless, right? The infrastructure days are 2005, 2007, 2008, right? They built the infrastructure. Now they're building higher level services to enable developers to work more rapidly. So when we're building serverless applications, right, I mentioned that a Lambda function, Lambda is effectively a function, right? So as a result, if you want to build a whole application, you're going to have a whole bunch of things going on. So pretty quickly, when you start building out your application, you end up with sort of a jumbled mess of various components. You have dozens of Lambdas. You have these API gateway endpoints that point to it. You have S3, the storage. You have buckets there, files you have to manage, and integrate, and all the integrations between those things. It can be pretty complicated. So to help you manage that, there's various tooling out there. One of them is called SAM. It's called the Serverless Application Model. It's a tool created by AWS to help manage and deploy serverless-based applications. There's another one I'll demo a little bit later. That's an open source third-party alternative. So what SAM is, though, it basically provides a way to take this jumbled mess and add some organization to it, right? So I can think about my application in terms of my application logic and not necessarily about all of the low-level resources required to make that thing run. And what's more, it allows me to represent the relationship between all of these components in a pretty manageable way. Basically, there's the YAML file. You define your resources. You define how they're managed. And AWS and this tool manage how those various resources are deployed and maintained. So it is natively supported by AWS, and it uses something called CloudFormation. So just briefly, what CloudFormation is a infrastructure as code service. So how many people have heard of the notion of infrastructure as code? Okay, cool. So so basically, the idea is when we go back to a data center, the only way for me to get a server in there was to physically move it, right? There's no way to represent that in code. The best I can do is have a diagram that represents what I did, and hopefully it's up to date. You can do the same way in AWS. You can go through in the console, in the user interface, and click through and create your resources and do all the work there. And it's kind of equivalent to like racking and stacking servers. It's your representation is your end state, not really your start state or your desired state. So the idea with infrastructure as code is, well, we as developers have been doing this a long time. We write code, we commit it, we do code reviews, we version it, we do diffs, we do branches. Well, why not do that with my infrastructure? It's all virtual anyway, right? So infrastructure as code is basically the idea that rather than clicking around and creating infrastructure, I create my state, I create code that does that for me, and as a result, I get all of those developer benefits as well. CloudFormation is AWS's offering for that. It allows you to, using JSON or YAML syntax, describe your AWS environment, and then it'll create it for you. So what SAM does, it takes a higher level than that even, and lets you describe it in even a more from application context, and does that CloudFormation generation. It is open source as well, and it's licensed under Apache 2, so it's a pretty great tool. It integrates with code pipeline and other CI/CD tools as well, so that you can get your commit, you can do a build from that, you can run some tests on it, and then automatically load that up into your testing or prod environment in AWS. So the key there is that when you're picking a serverless platform is that you start with tooling, you start with looking at the developer ecosystem, make sure that you're going to be supported there. So in addition to SAM, AWS has another offering to help with the debugging and metrics gathering, right? So now we've deployed our application, we have these dozens and dozens of components, and they're complicated, right? It's not as simple as deploying a simple Express.js app where I know the entry point and exit point, entry and exit points of my application. Here I have functions calling functions, deploying services, data flowing all over the place. To help visualize that and bring some sanity to the whole process, there's a tool called Xray. So Xray will basically let you visualize data as it's flowing through your serverless application, so that if there are issues, you can kind of pinpoint the problems. It'll give you stack traces. It'll tell you if you're relying on DynamoDB, how much time did I spend in a table running a query versus in my code processing the results, right? So it's really kind of critical to building and deploying these kind of complicated applications. So developer ecosystem, again, so we're writing code, building, testing, deploying, and Lambda serverless really kind of help. The tools really kind of help simplify that process. So and there are tools in a whole bunch of spaces. So we talked a little bit about SAM, that's around the deployment and management. There are a whole bunch of other ones, libraries, if you want to do SMS, you guys have probably heard of Twilio, integration layers with Zapier, and then a whole bunch of other stuff here as well. These are the third-party commercial tools. Open source-wise, SAM is one of them. Serverless is one I'll talk about in a minute. These are all around helping you manage and deploy your infrastructure, your serverless application. The last real kind of part about a serverless application you want to make sure your platform offers, which AWS does obviously, is orchestration and state management. So a shopping cart is a really good example. It's kind of a state machine, right? And kind of if you guys have ever been in a comp sci class or kind of looked at this, it's a kind of torturous concept. But basically the idea is that I'm following various paths, and each path is going to be a decision tree, and along the way I want to pass some state about what the previous entry did, right? So a shopping cart's a really good example. A user comes in, they're browsing for a while, they click on a details page, they add to the cart, cool, I have some state. They go to their checkout, now I'm in another state. I want to take their shopping cart and take it to the checkout step. Checkout has multiple phases, right? So these phases might be represented by different parts of your code, different Lambda functions, and you want to have a way to easily take that state, maintain it, and kind of follow along as you're building your application. So AWS step functions are what AWS has to help with that. So it's basically a whole bunch of Lambda functions that you describe how they connect together with a flow diagram, right? So as you make decisions, you transition between states, and along the way, the various state that you've captured along the way is captured and sent along for you. So as we've been talking about, serverless is a pretty fundamental part of modern applications. I mentioned what we do at Anika in my group is really try to figure out how we can leverage as much of these services from the start. So if a customer comes to us with a new application idea, it's not a hammer, so we don't want to use it for everything, but it's useful for most things and definitely part of every solution. So let's talk a little bit about the path. So let's say you have an application and you're trying to get there, which is the case of a lot of people. So we started with the legacy data center, and we're basically managing servers, databases, everything there. the first step that people take is to migrate to AWS, and that's basically those EC2 instances. So EC2 instances for everything. Then we have the opportunity of, once we've got our infrastructure set up, we have our instances working, everything talking together, we have some opportunity to offload some work to the platform. So there are some services here that these are not serverless services, so things like RDS. It's a managed MySQL, for example. You can offload that, fairly little work. But the reason we talk about cloud native being kind of a whole different experience is that you have to really kind of be engaged in from the start or willing to re-engage and rebuild your application is because the path from legacy data center to being in AWS is just operations folks. It's just guys who can go and who manage the servers and OS. They can do all of that pretty much without you having to change a line of code. When you get to cloud native, they kind of go away, and now we come into play. It's all developer work that has to be done here to get to the cloud native. So let's get into a little bit more detail about serverless development. So there are some things to know, some gotchas when you're going down a serverless path. So key here is code organization, testing, deployment, debugging. We'll talk about these in turn. So I've been saying that Lambda is a function, and I'm going to tell you it's more than just a function. So the reason Lambda is a function is because it's the entry point. So anyone do like C development or or Node with a command line app? You have like this entry point, a notion of a main method or a main function, right? This is traditionally where the OS or something invokes your code. It's this contract you have that the operating system will invoke this function, it'll give you these arguments, and you'll return this value when you're done. A Lambda function is effectively a main method, right? It's not the entirety of the application, it's the entry point into it. And that entry point is called the handler. I'll show you an example of what this looks like in a second. But the point here is that the handler is the entry point and not all of the code. So if you're building backend applications with Node.js right now, you're probably or hopefully in the habit of breaking up your logic into layers. You might have your controller layer or something that's receiving the event. Then that invokes an application service layer everywhere where your business logic is being applied. So what's a notion of an order mean? What are rules around placing an order? That'll tie into your data layer. So what sort of database are you using? How do you maintain and ensure the data integrity of your database? This is your data layer, right? So you've built your application in layers, and part of why you do that is to keep everything readable and maintainable and for your standardy. Part of it's going to be testing, which we'll talk about in a second. And you should do the same thing if you're building Lambda functions. So here is a sort of a typical Lambda function. And I'm trying to look. This is, this is close enough to call. I think some of the examples here are actually going to be TypeScript, so forgive me if you're like a hardcore JavaScript guy, but some of them are going to be TypeScripty. This one looks like it'll compile in ES6. So here's the idea. Here's what a handler looks like, right? I have a method here. I'm passed in a few parameters by the framework, by the Lambda runtime. That's event, this thing called a context, and a callback. Context you can almost forget about, it's sort of deprecated. Event and callback are where the magic is. Event is going to be, in the case of like an HTTP event, it's going to be the URL parameters, the path parameters, any data that was posted to you. Basically, all the data that came in from the browser is going to be represented somehow in the event object. The callback is how you tell the Lambda environment you're done and how you return results, right? And if you look, there's a handful of lines here, and one of them which is kind of this kind of blob that's setting up cores, so cross-origin request stuff. So that's not very interesting. The interesting code is actually hidden away in this service call. So I have this thing called user service that has a method called find user by email that's doing all of the work. And all I've done is extract a single parameter from the query string and pass that along. I wait for the result, and then I construct my response JSON object. So I have a status code, I have some headers, I have my body, which is going to be a JSONified user object, and then I call my callback. And the key here is that I kept my Lambda handler small, and we'll see why as we kind of dive into testing. So unit testing has kind of been driven to us. It's a thing we all should be doing. I'm sure we all are. It's even more important, I'd say, when you're doing serverless applications. if not for the only reason that testing your application end to end is a little bit harder, right? If I'm doing Express.js, am I saying? Yeah, Express application, I can run that all locally, right? I can test it all without having to deploy, without having to go through a long process. When I'm doing with Lambda, I have tooling that helps with that, but to really test it, I have to actually deploy my code to AWS. I have to create a zip file of that, upload it, have Lambda pick it up, redeploy it, and that could take maybe a minute or so. So if you don't know that your code is going to run at a basic level before you've done that, you're going to waste a lot of cycles iterating over that. So it's really, really important to do code testing, unit test coverage, and as much integration test locally as you can by mocking out your dependencies, mocking out the platform, and that really helps speed up end-to-end testing. You do need to test your application end-to-end, obviously, by deploying it, but you can do it less frequently than if you weren't doing that. So we're going to look at testable methods. So we saw that handler a second ago that was calling this find user by email. So here's what that business method looks like. It's a little contrived, I admit. Yep, definitely TypeScript, sorry. So this goes and requests some data from a database. In this case, it's actually loading up everything from a database. Then in code, it's filtering out and searching for the email address by using a starts with, right? So then I have a whole series of tests that are written in Mocha. So just a standard, you can use any sort of standard JavaScript tooling you want that you're used to for your tests. And I can run these things and test them all locally to make sure that this method is doing the right thing. So here I'm mocking out my repository. So this is going to be DynamoDB, let's say. I'm returning some various results from my tests, and I make sure that this code is going to behave properly. Then when I go and run it, the only issues I'm going to have are going to be wiring up things around AWS Platform stuff rather than my code. All right. So test your code. So the next big thing, and we kind of touched on it a little bit with Sam, is the components of a serverless app. So again, if I'm doing development with some sort of application server that I can run locally, think about how you work and how your colleagues might work. You have your own dev environment. I'm writing code. I'm deploying it locally. I probably have my own database I'm testing against. I have my own sandbox that I can run and test code completely on my laptop, right, without having to rely on anyone else and without having to share resources for the most part. Maybe if you have a really expensive database server, you might do that, but for the most part, we're not doing that. So, and there's no reason it shouldn't be the same way in AWS. If I'm working on a big serverless application along with 4 coworkers, I should be able to work independently from them without having to worry about stepping on their toes and them stepping on my toes. We might ultimately want to update the same APIs or same Lambda functions, but we'll deal with that at merge time. So it's really key when you're working in these environments, when you're working on these applications, that that you have your own complete environment that you're working in. Not your own AWS account, but all of the things that go in there. So you're going to have your own set of Lambdas. That's in the middle. You're going to have your own API gateway. That's your HTTP layer. You're going to have your own event sources, your own authentication via this thing called Cognito, which means you're replicating this a whole bunch of times. Once for each developer, and then once for your staging environment when you want to go test it, have your QA folks test it, and then once for production. So we talked a little bit earlier about this notion of infrastructure as code, because deploying these things manually and wiring them all up is complicated. So you want to use infrastructure as code, but CloudFormation is too low level. So yeah, let's do this one. So CloudFormation is a bit too level there. I'll show you what that looks like in a second. To represent these resources, it's a lot of configuration you have to do, and it's taking us away from the whole point of serverless, which is to think about our app. We want to think about what makes our application unique. So just as a kind of an example, you don't have to read all this, but this is what a CloudFormation template looks like for a hello world serverless application. Oops. So this is literally all this does, and I'll show you this running code in a little bit. All it does is it deploys a single HTTP endpoint that has /hello. When I do a get on that, so when I type that in my browser, it'll invoke a Lambda, and it'll return like hello world, right? And this is what you need to do in terms of provisioning all the resources in AWS to make that magic happen. There's a good reason why all these resources exist, why they designed it this way. It makes it very granular and easy to compose various parts of your app. But if all I want to do is hello world, I don't want to write this. So this is where serverless-specific tooling comes into play. So we talked a little bit about SAM. I'm going to talk a bit more about Serverless Framework, which is another third-party offering that helps with this. So the idea with these frameworks is to help with the things that you do most often in a serverless application. It's to take your Lambdas, your event sources, the permissions required to that, take the code, bundle it up, and deploy it. And you typically do that with a CLI tool, right? So I just write my code as normal. I describe my environment or my application in this higher level YAML file. And as opposed to CloudFormation, this is designed for serverless apps. I run the CLI. It packages up my code for me, deploys it, both the code and the infrastructure necessary to run it. Serverless function is largely composed of these 4 sections. So you have your service, which is just kind of a name. So if you think about if you're making a microservice, this will represent all the functionality of that single service. The individual Lambda functions, the events that are used to invoke them, S3, API, APIs, things like that. And then there's a more advanced section where you can kind of describe other resources you may want in raw CloudFormation as well. And that same hello world application looks like this in serverless YAML. So you saw the CloudFormation template. Here's what you would have to write if you were to actually build and deploy that application. So a little bit more straightforward, a little more accessible, a little more focused on code. So if we look at this, all I'm doing here is I give it a name. I'm specifying that I'm using AWS. So serverless framework is in theory platform agnostic. If you wanted to do it in Azure or Google Cloud, it has hooks into that as well. Then I define my function here. So here's my hello world. I point it to the code. So this is literally just a JavaScript file and a method that I've exported called handler. And I tell it that whenever someone goes via HTTP to my hello world path, to my hello path, then invoke my code. And that's it. So tooling lets me speed up my development. It lets me do some configuration management. So when I'm managing these multiple environments, between my various dev environments, my stage and QA environments, and my prod environments, it gives me the ability to kind of have some variables in there to manage that. So for example, a typical one is when you're provisioning how fast you want something to be. You want something to be faster in prod than in dev. So there's no reason to pay for it to be fast if you don't need it to be fast. So you'd externalize that request in a variable and be able to manage it that way. Talked about debugging, test it as much as possible, utilize Xray. So let's do a little demo here. So here's what we're going to demo here. This is a kind of a hodgepodge of serverless stuff thrown together to demonstrate the notion. So we do, like as I mentioned, we do a lot of IoT work. So here we're going to actually show a simulated IoT device talking to the AWS IoT service. This uses a protocol called MQTT. When events come in, it's going to actually split and fork off 2 different ways. One thing it's going to do is send it directly to a Lambda function. So Lambda function will get invoked, and I'll do some work as a result of that, saving the data into DynamoDB. On the other fork, it's actually going to send it to a service called Kinesis Data Streams. And what Kinesis Data Streams is all about is taking and buffering high throughput data. So IoT is a perfect example. You have maybe tens of thousands, maybe millions of devices out there. They're producing lots of events. Kinesis will take all those events and store them until you're ready to process them. We will process them, again, via a Lambda to show 2 different pathways. And again, store some data in DynamoDB. On the other side, we'll simulate a web application that will be able to access that data stored in DynamoDB. So here's what we're building and what we're demoing. Let me mirror my screen. Let's jump to code. Is that big enough? Good? All right, so here's my serverless YAML file. So we saw the hello world one. This one's a little bit more complicated because it does a little bit more. But it looks fairly similar. Here's my hello world handler from before. So it's still there. If we want to look, let's take a look at the code for that guy as a starting point. So here's all it is, and this is actual JavaScript now. So we have our handler method, the event and callback. Here, in this case, all we're doing is logging the event and invoking our callback hello world. So if I want to deploy that and run that, a second. Here's what that looks like, right? So I've invoked that code. So let's look at it from the AWS console. So I'm going to take jump into the Lambda service here, find my hello world handler. So the GUI is kind of nice to poke around and debug, and if you're just testing around some, you want to create a quick function to test, by all means do it here. When you want to get into building a real app, that's when you're going to want to use serverless pretty quickly. You're going to want to do nothing more than a couple quick tests in this environment. But the cool thing is here I can see my code. I can even edit it here in line if I wanted to. But what we'll jump into is actually look at the monitoring here and jump to the logs. Look at some events. And here is what the log outputs for that. So Lambda fires off a couple log messages on your behalf when the request starts and ends, and a report on billing. And then here's the actual event itself. So my console.log there translates into this. And here's what the event looks like when invoked from an HTTP API. Right? So I have the resource that was invoked. I have the path, the method, the headers that were passed in. You see a whole bunch of headers are passed in there. And then somewhere along here, there's query string parameters. I have none, but you might have some. You might have some path parameters. So this is how you'd get data in. So if we just kind of go along here, there's a few other HTTP methods. Then I get down into here. Here is my Kinesis version. So if you remember the fork at the bottom, this is listening to that Kinesis. And then somewhere over here, oh, here it is, I have a handler for IoT as well. So the way you actually interact with the IoT service when data comes in is you use a looking like SQL syntax to select data from the stream of events coming in. So that's what I'm doing here. So let's fire this thing up. So in this window here, I'm going to, I'll show you the code for this in a second too. It's pretty straightforward. This is my IoT device here. In fact, let me do this. JS Ninja meetup. So I'm firing off my application. All this is going to do is every 5 seconds, it's going to create an event and publish it. So imagine you have a temperature and humidity sensor out there in the world. Every 5 seconds or 10 seconds or so, it's sending some data to the cloud. And here's what that code looks like. A bit of setup stuff to kind of get the frameworks in place, some command line parameters. But ultimately, all I'm doing is using the SDK that AWS provides, pointing it to the host, setting up some certificates that you get from them, from the IoT console. And then every, looks like 5 seconds, I'm generating some random values and doing a publish to AWS. So it's been running for a few seconds now. So let's go in here and bring up the IoT console. Oops, test. And then I will subscribe to that. So basically, this is a simple way to let me view excuse me, data as it comes in. So here it is, right? So every 5 seconds or so, my thing is publishing a JSON message which has the thing ID, some timestamp, and then some randomly generated temperature and humidity values. So here I have DynamoDB, and here you see that when I first loaded this, the table is blank. So obviously what I want to have happened is data to be populated. So if I refresh this, you see I have my JS Ninja thing, the sensor that we have in this room, publishing data, and this is being updated every few seconds via that Lambda path. So if I keep, this is a little too small, too big. So I refresh this, and you look at that last column, that timestamp. Every little bit, it's going to update with a new value. So, and if you recall, if you look at this diagram, this is what's happening. It's going from the IoT service, invoking my Lambda is writing to DynamoDB, right? Then lastly, some other API stuff. So I have this things endpoint. So if I hit that, here is my payload there. So this is just showing me an array of all the things I have. So right now I only have one. Maybe we'll start up another. Give that a second. I have, and the same data, basically dumping it from DynamoDB here. There you go. The second one show up. So here we've built a pretty real-time IoT application with a RESTful front end. I don't have a UI obviously, but you could build that in any tool you want. Deploy that, and this was trivial to build and to run, and it's cheap. It's almost free, right? If I kept this thing running, I'd probably get a bill for $2 at the end of the month right now. So let me see. Anything else interesting to look at here? I think that's the gist of it. This one doesn't. This application doesn't necessarily do well. It has a couple tiers. So let's just look at the IoT handler for a second. So as data comes in, all we're doing is passing it to this repository, this data persistence layer, and all that's doing is writing that to DynamoDB here. So we're adding a receive time timestamp and then writing that to DynamoDB, again, just using the SDK. So all in all, this is like a couple hundred lines, maybe not even a couple hundred lines, maybe like 100 lines of real code here, and then some boilerplate. And I think that wraps things up. So I'll be happy to take questions now.